Thank you, and you're most welcome. Today we are looking at the concept of the trio protocol. What keeps us kicking, what keeps us sleeping, what keeps us waking, what keeps us going. So, welcome to my broadcast, and today's lesson is on the trio protocol. As you should be able to see, I don't think this is working pretty much as I expected, but the trio protocol is on screen. Okay, this should be able to let me pin this. Okay, so the trio protocol on screen there, which I would want to bring back up here, shows what we are focused on today, which is the three things that work together, the framework of understanding what we are doing in the physical realities of life, and how that affects our functions, our bodily functions, which is a function of the creation of what we call protein. So we have to define some words. We have been listening to a lot of speeches, and persons are confusing you with the word protein. Now, we do not eat protein. We could inject protein through steroids and peptides. So if you get an injection, you could inject a protein molecule into your body, but you cannot eat a protein molecule. What you are doing, you are eating meat or plants. That's the only two things we generally eat. All of course, some of us eat plastic and rubber. We know how we do that. Sometimes paper also, but paper would fall under the classification of plants. But we generally eat plants and animals. They go to our Plants would go to our small intestine. Animals would stay into the acidic pH of the stomach for a pretty long time, maybe 2 to 3 hours to 4 hours. If you have proper acidity there, that acid would really denature or uncoil the coil up portion of that thing which we call meat, and bring it out into a strand of polypeptides which has something called amino acids. Amino acids are basically letters. Just put letters on a, A B C C C E F G H I J K, a long string of letters. That's a polypeptide, and the amino acids are each letter. So what we are trying to do in the acidic stomach is open up this letter block that was really coiled up, open it out straight, and get something called a scissors known as peptin, which will come try to cut up this letter. So the scissors goes around randomly cutting, which would sometimes cut out one, which means one amino acid, one letter is available. Sometimes it cuts out 10, so that's just 10 that would go down later into the small intestine, and then down in the small intestine, this species of little protein gets cut up into its one particle called amino acids. So the letters of the amino acid chain, which came in on a piece of meat or even on some plants, this is what gets broken off one by one, gets to the small intestine, and then travels its way up to a portal vein up to the liver. That's for meat. And with plants, you have similar things when you have a plant with amino acids in the plant. And of course, when you talk about plants, you generally are thinking glucose. To supply glucose, plants goes to the small intestine for digestion. So because of that process, it's a glucocentric producer of well, glucose is a energy source, one of the energy sources of the mitochondria. Plants are its key supplier. Plants, you do get other things from plants, vitamin C and key antioxidant for the mitochondria. So once you speak about plants, you're speaking about water soluble support for vitamins, which are antioxidants such as vitamin C, which would help the reactive oxygen species that comes from the mitochondria to be taken care of. So a whole plant would come with vitamin C for that purpose. So the whole plant is supplied that way. Of course, when we extract things from the plants, we call them refined foods. That does not come with vitamin C. So we have to remember, if we have some refined breads or refined flours, we need to get something with vitamin C to put in also, to help with the mitochondria's health, because the mitochondria, of course, create this reactive oxygen species which needs to be taken care of, or else it takes care of us, cause us to become a little bit older and damage our internals. That's the daylight process, which is the mitochondria's process, which is what is happening when we eat in the day. Therefore, when we eat in the day, plants are going to supply glucose that's going to go to the mitochondria is going to consume some of the glucose, convert it into ATP. That would mix also some out byproducts, reactive oxygen species being one, yes, carbon dioxide and water being the main byproduct at the cellular side. But in the whole transportation, trying to get the whole electronic transportation change to create the process of the ATP, you have some other byproducts. ROS, liquid ROS or water soluble ROS is one where the vitamin C comes into play to help it, and then the vitamin B might has to be that those B water soluble B's comes in to help also. So it's critical we understand that a plant in its whole form with vitamin C is useful because it's glucose we are supplying. And you might have some plants where we might argue and say, well, this plant is better than refined foods because it has a lot of fiber, which would be anti-nutrient, and a lot of fiber, which would be slowing down the absorption of glucose instead of you drinking some kind of liquid fructose or liquid glucose like the apple juice. That would cause more challenges inside the copper pipes in the bloodstream in the liver. You would see it's better to eat a whole fruit than to juice the fruit, regardless of which fruit it is, because you would be supplying not liquid loaded glucose and fructose, but you'll be supplying a fruit in the stomach, which will take less, have less going to less glucose and fructose molecule going up to the blood system, because the fruit would have this catchment of fiber that will drag things down to the colon for the colon bacteria to have their time. Now, how does that fit in the trade protocol? When you think about this, you are thinking about number two. In the day, you are stimulating your body with the use of glucose. You are stimulating the production of insulin. You are stimulating the production of many other types of hormones that has to work to in sync to keep glucose regulated. Most of all, you are stimulating the function of mitochondria when you consume glucose in the day. Now, is there something they call overstimulation? Maybe, maybe not. But could you overburden the mitochondria in your flow of glucose from the gut to the cells of the body into the mitochondria? Because the mitochondria are actually the residents inside the cells. When you look deeper and you look closer, you would start realizing a lot of the challenge with the mitochondria comes from us not respecting it, understanding that yes, it consumes or translates glucose into ATP, but it is like a bank which has tellers. So let's assume every teller is a mitochondria. You don't have everybody flocking to the teller and say, give us the money. Run on the bank would kill the bank, right? You have a line, and in that line, persons come up in a casual, fashionable way, one at a time. The teller deals with that person and have everything done. She does her balance and check, so she does not make mistakes, and she says next. Now, if that is what was supposed to